So here is my model catapult. The catapult is an example of projectile motion, and that's the purpose of this experiment. My model in particular, I did after an onager catapult. I'm not sure if I'm pronouncing that correctly. And it's also called a Roman torsion-powered siege engine, and that's because there's already tension applied by twisting this rope here, but then there's another rope that's applied, and twisting that over and over and over again until it pulls tight creates torsion, and the more that it's winded, the more force is magnified, which creates a really strong resting potential energy, and the rope kind of ends up working as a spring tight without having an actual spring. And then when it's released, there's a sudden release of that tension that changes the resting energy into kinetic energy, which will hopefully propel the payload, which in this case I'm using a little rock, all the way that way, much further than the length of my arm, hopefully. And then here on this part right here, I have a crossbar, and that kind of controls the angle of the way that it's propelled. And my arm is 45 centimeters in length, just to start out, but I marked out quite a few meters just in case it goes a lot further, because mine's a little bit bigger than the models. Okay, so I have my projectile, and what I'm gonna do is I'm going to start twisting this. Make sure this stays out of the way. I'm going to do it all the way, pretty much as tight as it can go. I'm going to add my projectile, and then I actually have a little piece here to hold it. I think I screwed it a little tight. And then what I'm going to do is pull on my rope and release all of the tension, and it's going to change the energy. So I'm not sure if you can really even see how far that went, but it actually went past the last meter stick that I put in. So it's past 1, 2, 3, 4, 5 meters. Close to 6 meters.